Hello from me. I will try to be brief because I know that we're a bit back on time. I will make a brief presentation about GIS tools and other sources for climate resilience and for planning in general. Yes, this is the main idea. So, as you may know, the power of GIS to a very big extent relies on its dual nature in terms of being both be able to function as a table, have some attributes inside of it, but also as a shape, as a geometry, and as a feature class, let's say. So here we'll discuss a bit about the GIS functions, the attribute-based ones. A shapefile, a package, a GIS dataset in general can be understood. It is in its essence, among other things, a table. So we can pretty much use it and utilize it as an Excel file, make queries based on its attributes, on its characteristics, but also join different GIS datasets based on the matched attributes. For example, we can join the settlements of Cyprus with an Excel file of its population based on its name, and then to have a new GIS dataset that has the location and the shape of the settlements of Cyprus, but also the population of it, the population, and visualize and map and visualize the population settlements of Cyprus in this example in GIS. And also we can do calculations between the fields and inside the fields of a GIS dataset, as we could do it in an Excel file or something similar. But also, evidently, apart from its nature or its aspect as a table, let's say, it also has location-based characteristics, GIS dataset. It has topology, it has geometry, it has a shape, and it also has spatial relations with other feature classes that are in our system, in our GIS systems. So, in the same idea, in the same nature that we mentioned before for the attributes, we can make queries based on the location and the spatial relations between different GIS datasets. We can select where two different shapefiles intersect, or whether the features of one dataset are inside the other, but also can match different GIS datasets based on their spatial relationships. And so to join, for example, the settlements of Cyprus with the regional administrations of Cyprus, and then know its region, its settlement actually, which are the region that it is. And also we can, since it is a shape, it's a geometry, it has topology, we can also calculate geometry attributes. So for example, we can calculate the area of the settlements of Cyprus, for example. And then if we have joined them already with the population, we can then make additional calculations inside the field, meaning, for example, to calculate the population density of its settlement by dividing the population with its area. Now, for this, for the second section, let's say, we will make a brief overview of the basic and some advanced processing tools that one can find in GIS and can be very helpful for planning purposes. So one of the most basic, let's say, processing tools is the buffer that gives a proximity, let's say, analysis around a point or around a line or around a polygon. In the same way, another tool actually is Clip, where we can see when we have two layers, and we can overlay the overlay layer over the input layer and can extract and have the information of only inside the overlay layer from the input one, or a difference layer that we can exclude, let's say, from the input layer the area that is outlined and it's specified by the overlay layer. Continuing on these spatial relations between different layers and how we can work with them, we can also have the symmetrical difference where we have an input layer and overlay layer, and when we run the symmetrical difference, create a new output layer where it combines them, let's say, the symmetrical difference, more or less, of its between the two. Another very important, very useful geoprocessing tool is the intersector intersection, where one can combine an input and overlay layer, and in return and has as an output only the part of these two layers that are intersected. And let's say in the inverse, more or less, function, we can have the union geoprocessing tool, where two different layers are. We have the union of the relationship, and we know where they intersect, where they don't intersect, and we have all this information stored in the attributes. Also, another important and very useful geoprocessing tool is the merge tool, where we have two different layers and we combine them, we merge them in order to have the attributes and the information of both of them in one output layer. We have two final, let's say, basic geoprocessing tools that we want to present here. One is the dissolve, and with this tool we can see whether we have inside one input layer that is characterized in the field by different characteristics. We can dissolve the parts of the polygon that share the same characteristic, as you can see here with the yellow, purple, and green hats. And finally, the multi-participatory parts geoprocessing tool, where when we have in one input layer different polygons or points or features that are stored as one, multi-point, multi-polygons are, as one can say, we can run this tool and then separate them into different geographic entities. Now, we decided to focus on only two more advanced, let's say, approaches regarding GIS analysis, spatial analysis, in order to be able to, on the one hand, give you the basis, the foundation of GIS and some basic understanding, but also give you some examples of how one can use specific tools on planning purposes. So the one thing that we will focus here is the internal density estimation, which is actually a heat map that it's generated based on the density of an input vector layer using internal density estimation. The density is calculated based on the number of points in a location, with a larger number of clustered points resulting in larger values. Internal density estimation uses the density within a range, within a radius of its observation, to represent the value at the center of the window. And also, it incorporates an inverse distance approach, meaning that the points, that the features that are used for calculating the density that are closer to its cell plays more role rather than the more far ones. Larger values of search radius of this bandwidth that runs the analysis produce a smoother, more generalized density raster, while smaller values produce a more detailed raster. Heat maps or internal density estimation, as we can, it's more, let's say, technical term, allows for easy identification of hotspots and clustering of points. And also, as you can see on the right here, on this map on the right, we have we have Nicosia and how the density of points of interest are is identified in the city. And as you can see here, we don't have we have points for the whole Nicosia, and as such, we can see the functional density raster as identified for the whole Nicosia. But one important aspect and capability that kernel density estimation has is that we can have barriers for estimating this analysis. For example, if you can see the next example that we have here, again for Nicosia, but for the build density, where we had a barrier in the green line of the city, we can see how this affects and changes the resulting kernel density estimation, as we can see with the purple color ramp. Now, regarding a second the processing tool that it's more kind of also sorry about the kernel density estimation. Apart from having just run the analysis without barrier or with barriers and have some results, we can also specify specific thresholds that can be used to identify centralities, or at least high concentration and high concentration of the examined phenomenon. For example, here we have the non-residential activities of a city in Athens, in Alamos, in Greece, and we run the kernel density estimation for all non-residential uses. But then we specified 3 different thresholds in order to identify the centers of the city, the centralities of the city, with the threshold of mean +1 standard deviation. We have identified with blue color the neighborhood center. For the threshold of the mean +2 standard deviation, we have identified the in-between centers with yellow color, while with the red color, we have identified the city center, where we set the threshold of the density being bigger than the average +4 standard deviations. So we can use tools as the kernel density estimation, the heat maps, both as visualization tool and purposes, but also in a more robust analytical approach, where we set specific thresholds, or we utilize specific manipulations of the tool in order to have a more distinct result and more useful result for our analysis and for our planning purposes as well. The final geoprocessing tool that we will describe, which is a more advanced one, it's the attribute-based clustering or multivariate clustering, as you may see, which refers to one of the most widely used methods in machine learning, which are the clustering, grouping, and classification techniques. Specifically, the attribute-based clustering utilizes unsupervised machine learning methods to determine natural clusters in your data, meaning that these classification methods are considered unsupervised since they don't require a set of pre-classified features to guide or train the method, but based on the components of analysis that you set, identify areas, units that share similar characteristics based on your analysis and your purposes. For example, here on the right, we have an example of build density types, of build density clusters, let's say, where we have 2 separate, we set 2 different components of analysis, which was the ground space index, which refers to the coverage, the build coverage of the city, and the floor space index, which refers to the total building volume of the area. And we can see how, based on these 2 different metrics, we have identified 5 different clusters that refers to these different characteristics of the city. For example, in one case, we have very, very low, almost minimal ground space index and floor space index. So we have minimal build density. Or on the other end of the spectrum, we have areas with high coverage and high build-up volume, and we have dense high-rise. And this can be seen And these type of clusters can be mapped and spatialized, let's say, in our area of interest. Now, moving on to the data sources that one can use for climate resilient integrated planning. We'll focus on some of them that have on European coverage, and then we will also focus on the 4 cities that are in InPlaLabs consortium. For the pan-European coverage, we have some of the most important data sources that we have is Urban Atlas, that refers to the whole Europe more or less, and actually to areas that have more than that have a lot of inhabitants, and encompasses land cover and land use data products, a street tree layer that shows continuous rows of or patches of trees covering at least 500 meters of over artificial surfaces, and population estimates for Urban Atlas block polygons. Also, a very important, very useful dataset that Urban Atlas provides is the building height layer that describes both the building height of each cell, but by definition also the covered area, the built covered area of the city, with a very granular resolution of 10 by 10 grid. Impervious density is also an important data set that is available through Copernicus and describes the imperviousness degree of the city, showing the ceiling density in a range of 0 to 100%. And also Coreland cover, which is a less detailed data set rather than Urban Atlas, but it is available for the whole countries of Europe, and has a minimum mapping unit of 25 hectares and a minimum width of 100 meters for linear phenomenon. Finally, we have the tree cover density, which is a high-resolution layer tree cover density product that provides information for the percentage of tree cover in a given area. Provided at pan-European level and a spatial resolution of 10 meters and high 100 meters, and the tree cover density that goes from the range of 0% to 100%, and the latest available are 2019, the reference year. Now, the other dataset that we want to focus that have pan-European and actually global coverage is the OpenStreetMap dataset, which is global, free, and open. It is an open source and dataset that relies on cloud mapping by volunteers and interested people, and includes a multitude of attribute-rich datasets. But it has an important limitation, which is the degree of completeness and accuracy, which is also an issue, especially for geographic areas with specific features. For example, the capital cities of the countries are in a lot of cases in a very good level of completeness, while smaller cities and not so popular areas in a country are far less mapped. In the context of integrated planning, is one of the most relevant datasets that includes street network, points of interest, transport infrastructure, and also building outlines and land uses. Finally, when we're discussing about planning the city, one must be very aware of the city-specific datasets that are available. And this is not only refers to GIS data sources, but also to authorities and organizations that produce even reports or gray literature datasets that are very much important to understand the city, its planning approach, and stuff like that. So, starting with Athens, as expected, one of the most relevant data sources, the Hellenic Statistical Authority, which supplies a comprehensive data on socioeconomic demographic aspects, which are essential for city planning and resource allocation. Especially for Athens, there is a very informed, a very complete data source, which is the geoportal of the municipality, which has a catalog of the spatial data and thematic maps that are granular and recently updated for the municipality of Athens, for the city of Athens. Moving to less GIS heavy, let's say, data sets, data sources, the Athens Social Atlas is probably one of the most important ones, sources for understanding the city when we move beyond geospatial data sets, which is a repository of articles and insights regarding the social, but also the built fabric of the city. Just recently, the Thessaloniki Social Atlas was made available. So the second biggest city of Greece is also covered, or at least has a resource that can facilitate and support different types of sources, data. Also, Wikipedia serves as a valuable resource for exploring the historical and geographical dimensions of the Attica region, giving urban planners context to guide their strategies. While Participatory Lab provides extensive relevant resources ranging from datasets, but also methods, tools, and repositories for participatory planning, but spatial planning in general. And since it's an active community that is pretty much alive and continues to produce, let's say, documents and information about the city, in the same way that Athens Social Atlas is working, it's a repository that collects and documents multiple sources that are very relevant to great planning. Moving to Nicosia and Cyprus, again, the statistical authority is very relevant for searching for geodata sources, geodatas for socioeconomic, demographic aspects, and specifically population trends, employment statistics, and stuff like that. Also, the Department of Land and Surveys are important since it contains cadastral data on property and stuff like that, but also the cadastral of Cyprus specifically, among other things, includes administrative regions, parcels, plots, building footprints, and stuff like that. Finally, the National Open Data Portal of the Cypriot government provides a very important resource when studying the city, offer the possibility of easily and quickly finding different types of datasets, and to this end is very useful for planning purposes in Cyprus and Nicosia. Now for Gothenburg, we have a website that I will not try to pronunciate that supplies open geographical data and data online properties for all Sweden. And also national road datasets. Database provides the data on road, streets, including detailed transportation data. Also, population statistics for the whole Sweden can be acquired from Statistics Sweden. And with respect to contemporary plan developments in Gothenburg, this information is available through the Gothenburg City Planning Office. In the same source, one can download all building permits, including floor plans, situation plans, while the Swedish National Database hosts different datasets created within academic and research institutions. Finally, about Palermo, the National Institute of Statistics is a primary resource of information, offering comprehensive data on demographics, economic indicators, stuff like that, while the municipality of Palermo has developed an open data project, as it's called, where you can find data information regarding different aspects of the city. And also the city of Palermo provides technical documentation regarding the city planning and stuff like that. Finally, we have gathered two other important data sources, which is the Open Data Sicily and Palermo Hub, which provide maps with advanced search and filtering capabilities. And finally, for data concerning the environment, the ISPRA Institute makes available various data at the national and regional level. Before concluding this presentation, I would like to highlight that all this different information about the different cities, Athens, Nicosia, Gothenburg, and Palermo, have been made available from the from the different partners working on the project, from NDUN commonspace for Athens, from the University of Cyprus for Nicosia, from the Urban Calculator for Gothenburg, and also from Bond of Union for Palermo. And among other things that are, among other cities, are available and accessible through the InPlaLabs wiki, where we have a specific, let's say, entry point, which is called Cities Insight, where we have gathered all of our collective, let's say, experience for the different cities involved in this project, but also we have invited the members of the network to provide their own insights for their own cities. And we have a pretty extensive, let's say, information also about Paris, Rome, and Barcelona, if I'm not forgetting anything. This was all by me. Thank you very much.
Yes, hello again. I will now move. I will present two digital tools: the Place Syntax tool and the Urban Calculator, as Phrixos said. We have been developing these tools both in the Spatial Morphology group at Chalmers University and with the spin-off company of the group, that is the Urban Calculator. And like I said already from the beginning, we are a research-based startup and a spin-off from Spatial Morphology Research Group with the aim to bring research expertise back to practice and to make evidence-based design an integral part of urban practice. And we work within the methodological framework I already presented, and to be able to facilitate the type of analysis we want to do within this methodological framework, we have been developing two tools. One is the Place Syntax tool, which is an open source plugin for spatial analysis in QGIS. We have been developing this since with KTH and Spacescape. It started around 2005 as a plugin for MapInfo, which was a proprietary software, and then around 2018 we moved to QGIS, which is an open source, an open access platform. This is primarily, this is a very advanced analytical tool. I will describe it later, primarily targeting advanced users, GIS users, researchers, analysts, specialists. So it has a broad user base by research institutes, universities, and big consultancy firms, and even practices, but big, for example, Foster and Partners use it, or Ramboll in Sweden, and so on. On the other hand, as a spin-off from the Place Syntax tool, and running with Place Syntax tool in the backend, is Urban Calculator, which is a design-oriented design support tool, a kind of a light version of PST, developed by the Spatial Morphology group again. And this targets mostly designers and planners, novice users, students, people with no GIS background, and so on. Both tools have the same developing firm, XMN Software, and Martin Fittger is the primary developer, and they use the same principles. So I will focus more on PST and then give some more input on some more information of Urban Calculator, because Urban Calculator will also be presented with also a hands-on exercise in a mini course later in the summer course. So the PST combines space syntax descriptions of the urban environment with conventional descriptions of attractions into a combined accessibility analysis tool. This is a kind of a strong point. The original thing about Place Syntax tool is that it combines conventional space syntax centrality analysis of the street network, but also it opens possibilities to include attractions in the analysis as origins or destinations. Like I said, it is open source. We provide in our website full documentation, of course the tool, but also tutorials and training data and so on. And I have also, we have offered all of these open educational material resources for the InPlaLabs wiki that will be shared with you. So it is important to understand again that we are making these tools to facilitate analysis within the methodological framework that I already presented. So how to analyze street network centrality, build density, accessibility to attractions, how to combine these different analyses in different scales and so on. The tool is not only open access, but also open source. For the advanced users and people who are familiar with coding, they can download the code and kind of manipulate it, change it, add functionalities if they wish, with the obligation to return and also publish as an open access and open source their code. So that's the only basic obligation that they have. So like I said, PST is a plugin for QGIS. It is a functionality within the vector toolbar. This is the kind of a landscape, if you will. As you see, it combines the space syntax analysis, so network centrality, different measures of network centrality. We talked about betweenness, integration, reach, network reach, catchment, but also attraction accessibility analysis. Again, we talked about attraction distance, distance to the nearest, attraction reach. We can use these two functionalities to also calculate accessible built density, accessible floor space syntax, accessible ground space syntax. Attraction betweenness you can do, which is a network centrality analysis weighted by attractions. All of these different measures are combined, as you see, with different settings, with different distance modes, with different cutoff radius. You can use walking distance, straight line distance, angular distance we talked about before, steps, which is topological distance. So there is a huge flexibility. For networks, you can also use as a street network representation different types of maps. You can use axial map, which is a kind of a traditional representation used in space syntax, but also road center line maps, segment maps, using road center line maps, for example, OpenStreetMaps and so on. So kind of a ready-made accessible network data set. On the other hand, there is a huge flexibility also in the types of origins and destination. One inputs in the attraction accessibility analysis. Point lines or polygons can be used as origins or destinations. For the analysis, again, different distance modes. One can weight the destination points or the origin points with attributes. Yannis talked about this adding the attribute that the geometric features have in GIS. So these attributes can be taken into account in the analysis. So not only how many, for example, schools are reached, but also, for instance, how many students are reached, if students are an attribute in the data set of schools. There is a new function that we added, which is a compare very recently in the latest version we published. It's a compare results tool that is that aims to support informative before-after visualizations. I will show you an image later on. Another important thing is that within the tool, one can also do the network editing. So process and edit network data sets that even come from, for example, OpenStreetMaps or these official datasets of road datasets that Yannis also mentioned previously, but that need some kind of processing before one can use them in network analysis, especially space syntax analysis. So this editing can be done within the Syntax tool. So to summarize a bit, the tool offers a high flexibility and many different choices, especially for the advanced users who actually are familiar with which settings to choose and how to wisely match representation and analysis. For example, what kind of network they use with what kind of analysis they can do, and so on. It can calculate different distance modes, use different geometric features as origins and destinations, and so on. So just a couple of functionalities. I will go very fast here because we talked about that previously. But for instance, we can analyze both centrality measures, integration and betweenness for different scales, local and global scales, for different networks, for the non-motorized or the motorized network. But also we can do network integration and betweenness if we use as input an axial map, or angular integration and angular betweenness if we use as input a segment map coming from a road center line map, and so on. So different, again, high flexibility in the results. So the user can match wisely the network representation, for instance, with the right measures, and then other analysis settings, which is different normalizations that need to be used in a centrality analysis, the different choice of radius from local to city scale or regional scale, options to weight the analysis by length, and so on. Like I said, the network editing can be done within the Syntax tool, and then it can use as input both axial maps or road center line maps that can be downloaded from official data sources or from OpenStreetMap. Some basic cleaning of the network is done at the back end, error fixing, removing duplicates in the network, snapping. You can do removing null values and so on. And some basic also, the user can choose to make some basic geometric editing, for example, to snap, like I said, but also to generalize. I mean, these are some processing steps that are needed when one works with available road center line maps. The other functionalities that have to do with accessibility analysis. On the other hand, we talked about these two main measures we use that Syntax tool offers: attraction distance and attraction reach. Sorry. So distance from an origin to the nearest destination, or attraction of certain kind, or total amount of attractions that can be reached within a certain distance from the origin. Again, the important thing here is that the user can choose different origins in terms of different data sources, points, polygons, lines, for instance, address points or location points or business points, building polygons or park polygons or square polygons or street lines. The same with destinations. An example here, again, attraction distance to the nearest school or attraction reach to the nearest school. Or attraction reach to schools, sorry. So what we see here is that this flexibility allows us to ask many different questions. For instance, if we take attraction distance as an example, we can ask how far is each house from the nearest school, park, supermarket, public transport stop, how far is its office from the nearest healthcare center or gym or square or parking lot or shop? How far is a university from each university from the bar or supermarket or pool or bakery, bookstore, and so on and so forth. And then that you see in black the different origins that we use, and in orange the different destinations. So you can switch from origins to destinations and create a huge set of analysis. The same with attraction reach. How many workplaces or stores or schools or parks can be reached from any house within a 500-meter walking distance? How many public transport stops can be reached from any school within a 1-kilometer walking distance, and so on and so forth. Again, flexibility on the different destinations, different origins can be used depending on the data sets one has available. And then here you can also choose different radii for the analysis. And one can analyze the same thing with the different choice of origins that have to do also with how one wants to visualize the results. Do you want the results on a building level, on a street level, or on an address level, for instance? So here is an analysis of accessible gross floor area in 500-meter walking distance from every building, from every street, or from every address level. And you can weight attractions. So here we do not ask how many buildings are reached within a 500-meter walking distance, but actually how much gross floor area is reached. And gross floor area is an attribute within the building polygons that are used as destinations. So we can weight the analysis with attributes. And that's the new functionality we have added. I selected to also show this one, which is, it's called Compare Results. And what it does is that we input two different networks analyzed, for example, for centrality. And then we can compare easily. So the tool compares value from, for example, an existing road network and the value from a future road network. So here in the image, you see when a bridge over the river in Gothenburg is added, what is the change? What are the effects of this change in the network centrality? And then the measure that is compared here is angular integration on a city scale. You see the value in the field. And then what is outputted automatically from the tool is a gradient raster layer or a polygon layer that actually visualizes the changes in red or blue spectrum if it's a positive change, or if it is an increase in centrality, and in blue if it's a decrease in centrality. And then you see with darker red where the changes, the increases in centrality is the highest. And that helps actually to, it's kind of a heat map, if you will, in relation to what Yannis showed before, but actually visualize the magnitude of change. And that helps us see that the impacts of the interventions in the street network, for example, here, are not only localized where the intervention is happening, but actually spread around in the city, in different neighborhoods, further away from the area of intervention, and can bring increases, but also can bring decreases. So you see also that there is a blue, an existing bridge has a blue color. That means that its centrality in relation to the new bridge is decreasing because there is another bridge added. Now, a few minutes I will talk for the PST spin-off that I talked about, which is the urban calculator. And there, like I said, the aim was to, because the PST is quite advanced and it provides high flexibility and many choices, but that on the other hand was a little bit of a intimidating, so to say, for the designers, the planners, or the novice users. So we really wanted to create a version of the tool that is more of a digital or design oriented. It's a design support tool and it's something that could be used by planners and designers with the aim to bring the analysis within the design process and not have the analysis as done by consultants at the end of a design process. Because this is what is currently happening. Because like I said in the beginning, if you have an assessment, if you have an analysis of a proposal at the end, even if you see that things are not performing as one would have expected, it's very late in the process. It's very hard to do any meaningful changes in the design. So we need to bring the analysis as part of the design process of the design iteration, and this needs to be part of the design routines of the planners, of the designers, the people who actually are doing the design. So we need to give some kind of expertise and empower, if you will, the designers and the planners, give them the tools, the means to use the analysis as part of their design routines. So using a focus group to identify the reasons why designers and planners, although they understand the need for the analysis and the analytic evidence and the need to have quantifiable measures in order to have the tools to negotiate, to argue for their proposals, especially in an interdisciplinary teams. The main problems we identified is that the most designers and planners do not have GIS knowledge and do not want to have GIS knowledge. They use design tools like AutoCAD and so on. They want something that is very user-friendly. They do not have the means or the resources or the expertise to collect the data that are necessary for spatial analysis or to process them. And also they are not confident in choosing the proper analysis settings and communicating to other people the results. This is very hard to communicate in a meaningful way, to understand the results and to reflect on the analysis results. So in Urban Calculator, the dataset is already provided to the users. They are customized for different cities. We have Urban Calculator for Athens, for example, for Nicosia, which we will offer. We offer now some educational licenses. The analysis settings are controlled. 4 types of analysis: centrality, accessibility to services, proximity, and accessible build density. So the main things, the main pillars, so to say, of spatial analysis. So the users, although novice, are confident that their results are accurate because we have controlled the analysis settings, and also relevant because we have put in the tool the analysis that we think are based on our expertise and experience that are the most relevant to include. And then within the tool, they can easily design and intervene in the street network, for example, and very easily get before and after visualizations of the different measures with short explanations on what the measure is, what does the map tell us, the legends are there that make sense, that are accurate, and so on and so forth. Like I said, I will finish here and refer you to the mini course that will happen on June 12th, where you can actually use the tool, and also we will share all the tools and resources. Yes, I will end now here. Thank you.
So this is the second part of the digital tools for analyzing the built environment. We will be speaking about the Space Syntax Toolkit as well as STAMP. So this is an introduction. We will be looking at a number of concepts which were introduced by Bill Hillier and his colleagues at the Bartlett at UCL from the 1970s onwards, looking at the social impacts of architecture and urban design. And these are mainly explaining why buildings and master plans weren't working the way we wanted them to. So we all know people naturally pass through some spaces more than the others, which is called the natural movement. It's basically about how urban space shapes how people flow. And this then leads to the movement economy, which is about how land uses shapes movement. And then we move to the centrality, how cities create multiple centers and overlapping neighborhoods. And finally, the dual grid system of cities, which is basically about how the foreground network and the background street network works together. These kind of ideas explain how cities work. And if you like to delve more into this, you can also have a look at these books. So firstly, what is meant by the term space syntax? When we refer to space, we are doing this in two main ways. Firstly, we are interested in the public spaces, streets, squares that make up the city, which is what is called the space in between the buildings. And at another scale, we could be interested in the space inside the buildings. And secondly, what is meant by the term syntax? So in language, syntax refers to the limited set of ways in which words can be arranged to create meaning, underlying rules for the arrangement of elements. So we can understand this that these are the limited ways spaces can be brought together to produce livable cities, livable buildings, which is also called the spatial configuration. And this basically refers to the relationship of each space to all other spaces in a given system. Now that you know what the term space syntax mean, let's take a look at the Space Syntax Toolkit, which is basically a plugin that you can install in the QGIS software. And through this plugin, you have 8 different kinds of analysis. Today, we are going to focus on the graph analysis, which basically performs the space syntax analysis by remotely connecting it to the depth map software. So you basically need 3 softwares installed: the QGIS, the Space Syntax Toolkit, and the Depth Map X. Now we move to the space syntax analysis that can be performed using this toolkit. So before moving into the analysis, let's say, what will we analyze? So we basically analyze basic features of each street. You can analyze the length of street, number of connections to other streets. And there are 2 main important key measures that you've heard of during the sessions. The first one is integration, or closeness centrality of each street, which refers to how close each street is to all other streets in the system. This is also known as the two-movement potential. And the second key measure is the choice, or betweenness, which refers to the streets that are likely to be chosen as you go from one part to the other in the system. And this one is also known as the through-movement potential. Now, the next aspect is the scale of analysis. So it is important to understand the connectivity of a street segment to all other street segments within a given radius. And this is basically according to your recess question. If you want to understand the connectivity on a citywide hierarchy, let's say, you can use radius n. If you want to understand the connectivity on a local movement or a walking distance, you can use the range of radius from 400 meters up to 2 kilometers. If you want to explore larger scale citywide movement or vehicular movement, you can use up to 10 kilometers. And if you want to explore the region or the countrywide movement, you can use up to 100 kilometers. And of course, these scales differ depending on the city, from one city to another. So these are the scales of movement. And one of the important things in space syntax is that being able to look at the same place across different scales and see how important it is for movement across different scales. The redder here indicates higher choice value. So at one scale, it could be green and then red at a much lower scale. Successful centers can be accessible at both the local and the global scale. Now moving to the spatial analysis, there are three main properties that we explore when we look at the spatial syntax of cities. The first property is that it's called the accessibility measures. Streets have different accessibility measures. Some streets are easier to get to from everywhere else, so they are better integrated. And some streets are more useful in hosting the through movement. They are known as having a higher choice value. The second property that we mentioned before is the dual systems of streets, that cities have an integrated system composed of a foreground network, which refers to main streets, and this is supported by the background network, which usually refers to the local streets. And finally, the third property, which we have also discussed, is the scale of movement. We know that movement happens at different scales, and when they overlap, they create urban centers. So it is the overlapping layers of local and place-wide movement, which creates the centrality at different scales and the sense of place. Now, we will explain more the two key accessibility measures that you can explore using the tool. As we explained previously, the first measure is called integration, and this is to answer the question about how central a street or a place is in an urban system in relation to all other streets in the system. And the second key measure is choice, which answers the question of how likely a street or a space is to be used as people go from one point to the other within the system. So these are examples to the two different types of analysis. In the picture on the right, you see integration or closeness centrality. Basically, this highlights central areas, as you can see the highly integrated core in the middle, while the picture on the right highlights choice or betweenness centrality, and the red streets highlights the routes that are most used to move through the city, and this often identifies high streets. So one of the key things we look at space syntax is the depth of each street to all other streets in the system, not in a crow-fly distance, but rather the number of turns that people would have to make to get from one point to the other. As I mentioned before, it's the angle of the turns. So no surprise, centers are shallower, but at smaller scales of movement. Subcenters too. So the closeness centrality based an idea of spatial configuration and spatial depth. Again, it highlights the principal commercial center of the city and where people move to. But we know that cities also consists of multiple small centers where local grid identification and structure highlights accessibility. So this is just an example that you can run these analyses on different scales, different radius. So you might, for example, want to see the total depth of every space only within a small radius of 2 kilometers from any given point, global or local. So this picture, for example, picks out the local towns that surrounded the city areas. So you can see from this picture the local centers in each municipality or in each town. And again, a slightly different variable is what we call choice, or what in the network analysis is called betweenness centrality. And this is about how likely that the street will be used for overlapping paths through movement as people go from one part to the other. In some senses, this is a byproduct, but it creates busier main streets. Now we have explained property 1, so we move to the second property, which is the dual system of streets. So the spatial networks typically combine a well-connected foreground, which basically refers to the main streets, and a less well-connected background, which basically also refers to the local inner streets. So this in turn creates an integrated double-layered system in cities. Foreground network is made up of longer, more open lines and consists about from 3 to 7% of the total network. It creates more organic blocks, and as can be seen in this map, and the background network is made up of shorter lines, which are easier to walk. So the background network can be more residential and often much with more cultural variation, whereas the foreground network often support trade, which is a common foundational dimension of cities, bridging people and through the urban fabric. So now we move to the third property, which is about scale. We all know that movement happen at different scales, and we measure movement at different radii. For example, we might go to the most accessible streets within a 400-meter radius to buy our coffee, or within a 2-kilometer radius to assess our place of work. Some streets are more likely to be assessed for local trips, while other streets are more important for citywide movement. But you often get places where there's an overlap between both scales, both the local and the citywide movement. And here you have a high sense of place. So the overlap between these different scale of movement creates what we called pervasive centrality. Now we move to the outcomes of the analysis, how you can interpret the analysis. So we have learned how spatial layout impacts many different factors, from direct movement to land use, economic vitality and land value, crime and safety, and even carbon emissions, health and well-being, and many other variables. So at the most very basic level, street systems influence pedestrian and vehicular movement. So basically, the accessibility of the street system is identified purely by a property of the street system itself, how close or deep each street is to all others. And however, this has proved to offer a strong predictor of actual movement, drawing on studies and analysis since the 1970s. So this image on the left shows the correlation between the spatial accessibility value and the observed pedestrian movement. So you can see how spatial accessibility actually shapes movement. Statistical effects, people still going from origins to particular destinations, but tend to move around street systems in a similar way. So we have long been testing the models by having people counting pedestrian and vehicle on streets, and this can be a good opportunity for citizen engagement in testing models for themselves and building their own evidence-based, let's say, predictive model. We also know that movement patterns have an impact on land uses and economic activity and the potential for economic activity. So, for example, this is an example of how spatial network can shape the location of economic activity. So in the picture on the right, you can see that the red buildings are actually retail establishments. So normally we used to think that shops are attractors in the system, so they attract customers. However, we have come to realize that retail location is an emergent property of street systems, and based on the street accessibility value, then of course the multiplier effect as shops attract their own customers. So in the picture on the left, you can see that 80% of the shops are located on the 20% of best connected streets in this part of the city. So the line with the red color also highlights the same line with the mixed use economic activities in the picture. And now we will explore this last section shortly to explain how we can understand these more complex outcomes, such as the health and well-being and other variables, through combining our understanding of street systems with other variables and layers. Of course, the toolkit can also be used to test design ideas, option testing, scenario testing. So for example, in this project, you can see the pattern of spatial accessibility created in option 2 is stronger than option 1. You can look at the triangle in the middle of the picture. These are two different options, but we can see that the second option works with the existing spatial hierarchies. It is well integrated with the surrounding context, and it connects spaces with high levels of existing movement. So it's another way of using the toolkit if you have to test different scenarios, not only on the urban or the city scale, you can also test it on the building level. Now, moving to another point, which is understanding complex outcome, and this can be basically done by adding other variables. So laying spatial networks with other forms of data in order to be able to answer complex questions. This is what is also called integrated urban models. So in order to look at the interaction between different variables in the city, to be able to understand more sophisticated spaces, you need to take other factors into account, such as walkability, codependency. So for example, the walkability index analyzes the families of land use that can be assessed within a 15-minute walk of every street. So the time here is not just a number of turns. A higher score indicates more families of use within 15 minutes and more walkable streets. This model can be used to answer questions like where do people walk, combining analysis of street networks with other local factors such as land use, ground floor frontages, and public transport to be able to understand what actually affects walkability. The second thing you can explore is the car dependency index. For example, it incorporates more factors, including car ownership and also accessibility to jobs with or without cars. In a study, local public health officials found strong correlations between the car dependency index and adult obesity estimates. Overall, there was a strong link between socioeconomic deprivation and obesity, but in more walkable areas of the city, this link was broken. Now we move to other examples of tools that help you explore complex questions. There is a tool called LINE, which is Local Insights Explorer. So it is a web-based mapping tool. You can that combines basic network properties with more complex data like the walkability, census data, and behavioral data. So in this picture, buildings are colored based on how walkable the built environment is. Red is for easier environment, blue is for difficult for walking. So the red areas here, you are able to understand the points where you can actually intervene and create policies to be able to improve walkability in areas that is already difficult to walk. So in this case, you are able to identify opportunities for behavioral change. This is another example of another tool. It is also developed with an integrated urban models to apply urban planning strategies. It is called the Active Travel Explorer, and you can access it via your browser using this link. This tool helps users to understand how the built environment can enable or inhibit daily activities such as walking or cycling. So you can explore with the tools to show you areas where active travel infrastructure is available or encouraged, and many other questions. So for example, where does the city support walking and cycling? Where does the city does not support such activities? And the last example is called here, Healthy Environment Risk Explorer. You can also access this tool within your browser, and this helps the user to understand the links between the built environment design and complex health outcomes, to be able to take targeted actions to address them. So from the picture, you can explore research questions related to access to jobs within 15 minutes, access to healthcare facilities, access to retail services within 15 minutes, to primary schools. Again, it all depends on the research question. And okay, this was it for the Space Syntax Toolkit. And now we move to another tool, which is more simple, more easy, friendly to use for everybody, for students, for practitioners, for urban design professionals. So it's one of the quantitative tools to analyze the built environment as well, and it's called the Sustainable Toolkit for the assessment of master plan. As I said, it's free, accessible, and easy to use. It's simple and can be used immediately by anyone in order to assess the master plan. So this tool functions as a self-directed reflection on a master plan according to predefined 14 categories. So it was created through a collaboration between ALA Planning Partnership Consultancy, the Society and Urban Form Research Lab, and the Software Engineering and Internet Technologies Lab at the University of Cyprus. And the tool is basically designed to assist built environment professionals to self-assess their master plan design through the design process from initial design to final design and construction. Academics is teaching and learning tool to assess the teaching of architecture, planning, and master plan students and inform them about sustainability principles and how they can incorporate it into their designs. And lastly, the professionals in the public and private sectors as well can use this tool to support them in assessing the sustainability of a proposed master plan. So basically, there are 14 categories, and the users are asked to add ratings from 0 to 3 in each specific criteria and considerations. And then the final outcome is that the tool gives you a score and a visual representation according to your responses. The chart here represents a project degree of sustainability, and based on that, you can create comparative evaluations, which will allow you to understand and change the master plan and maybe analyze it again to go back and forth. So it's just a quick tool that gives you a score of how sustainable your master plan is so that you are able to tackle relevant issues. So that was all from my side, and thank you.
So, sorry for this small delay. We had a small technical issue. We're moving forward to this last part and also the conclusion of this first glance of what participatory means and how it is realized. So in order to add to this toolkit that's already presented from my colleague regarding spatial planning and understanding of the space, now I will give you some examples of participatory tools, and through an example that we ran in commonspace, I will show you at the same time what tools we used, but also how this participatory workshop was formed and implemented in practice. So when it comes to tools, I already mentioned it before, but here we can summarize somehow some things that we take into account when it comes to selection of tools when we are ready to go on the field. And some, let's say, more specific ones beside the objective and the group that we have and the method that we use, as mentioned before. Here we can also add the geographical, for example, and thematic scope of the workshop, the mode of communication that we have, because in some cases it is not, when we have physical and digital means in our toolkit, we have to take into account if the target group, for example, are digitally illiterate, so they can use the complexity somehow of this kind of tools have. So here it comes also the skills and resources required, and it's good to know not only from our point of view, but also from the user's point of view, what are their skills and in which level we can actually go. The planning phase that we are, something that we didn't show in much detail before, because if we are in the initial stage and we are in the visioning or goal setting of the planning, of course, we will use different tools in the comparison if we are at the planning actually and co-design session. So having all this into account, we will eventually lead to the final choice of the tool that we will use. The available toolkit, of course, have a set of physical tools that we can use on workshops that are on the field. But we will see also a list of tools that are already that also can be used in order to ensure digital collaboration. We will also mention what are the benefits of both types of involvement. And finally, especially after COVID, where a lot of such processes moved in the digital world under force, we didn't have a choice. So then we saw an increase also in the hybrid version of workshops where digital tools are used also in physical settings in order to increase the participation, to create some more creative and inspiring environment, and eventually increase the interest of the participants. So, in order to focus on some aspects in how we visualize this kind of workshops and how we implemented it in an example, I will present you briefly the case of ISL project, which we ran, which was an Erasmus Plus project that we ran with commonspace in 2023, which had as a focus. We were in the initial part of planning, and we visited an island in Greece, Leros Island, where the target was, first of all, to capture the value and the let's say the value of the island and its cultural resources to the residents, and then co-create with them the vision for the tourism development of the island in 10 years from now. So we are at the very initial stage of the planning process. So we are in the visioning stage. And in order to achieve this, we used, let's say, a mixed method approach, including mapping, co-creation of cultural routes in the first day. In the second day, we used one of the proposed routes co-created with the participants and walk with them this route, because in order to see, to collect more data and experiences and understand further how they interact with the space. Then we presented some good practices as a middle stage in order to inspiring them on how sustainable tourism future would look like, but only in the, it wasn't a method to show them this is the way that you want, that you should go and choose these versions, but in order to create a vision, you need to know also some specific terms, like what is sustainable development, why it is essential, how other countries and other cities similar to your own context do such kind of practices. So it was an inspiration process to also inform them and create new valuable knowledge on how we can move further and create our own vision. So here you can see some pictures of the first day, where we had a small group of representatives of different associations and local networks, and also the municipality. Because Leros Island, it's not a touristic island, but it's mostly cultural oriented. We saw a lot of different cultural associations representing the historical society, bicycling society. We had an Italian, because Leros is related a lot with the Italian occupation during World War II. we saw also an Italian and Friends of Italy association. So we tried to gather different representatives of the different aspects of the island in order to have a very broad view of all these cultural elements of this. Of course, due to the resources, as I said before, and the timing that we had, because we had 2 full days to exploit, the target group was set around to 20 people in order to be able to manage this group. Here you can see that in the first part where we tried to, first of all, in the first image here, you can see some notes of the ice-breaking part that we had, where we invite them to bring something from home and explain to us what the island means to them. So with this process, they started sharing some experiences and information from their own connection with the island. And it was also a small, brief exercise to help them open up, all of them, and starting to connect as a group. Afterwards, we had a mapping exercise where in the first part of this exercise, they indicated on the map the most significant cultural elements of the island. It wasn't necessarily landmarks, but it would be some specific points that they value as important for them. And then we asked them to connect these different elements in order to create some routes. Here, and then the next day, because as I said also before, each group is different and you never know how this workshop will end up. We asked them to create this route. And because there was a village with a very particular importance for them, they all together decided that this is the only part that we should walk, and they left it outside. They put only one point on that, and they said, okay, this is something that we will walk and explore further the next day. And that we did. So we planned all together the next day, the next morning, and we walked with them this village together. Then we did a collective walk where they were somehow the guides, and they explained us some parts of the village, and they also pointed out some experiences that they have and some problems that they face when they live there. And all this information then were analyzed by our team, and it was presented to them afterwards. Here we can see the mapping result of both these 2 exercises, where here is the village I mentioned. So here we can see that after the walk, we have a more specific, dedicated data about it. And here we can see all the different points that they mention around. The different elements were about architecture, gastronomy, very nice points for sea view, and also some other local traditions and fests that take place in specific villages. So it was important to indicate them on map. After doing that, we passed through the visioning process, where in the first part, we wanted to capture how they stand against tourism activity. So we asked them to explain a tourism activity a tourism experience that they had, even it was bad, even it was good, in order to, let's say, make them put them in the position of they become the tourist of the island. And then we passed through the visioning process, where through 4 specific questions, we tried to lead to a consensus and create and co-create a vision of the island. These categories that we asked them was, we can see here that it was a brainstorming session. So through these 4 questions, they responded to the following aspects. First of all, what type of tourist we want? What is the target of the tourism activity on this island? What do we offer as a destination? And what are the values that should, let's say, somehow blend the tourism sector of the island? Based on their responses, and after several hours of discussions and debating, they decided that the tourism vision focuses on visitors that could actually value the cultural, the history of the island, and they visited it on a regular basis. So they wanted not only visitors that passed by, that more permanent visitors that can be eventually be part of the community. That's why the values that they selected was reconciliation, tranquility, and harmony. So in order to see how this was a totally physical workshop. So when it comes to tools that we need, as we saw also in the different images and the different stages, here in this image on the left, you can see also an example of another workshop that we had that had also a mapping experience, where you can see another way of mapping. In one case, we use stickers. In the other case, we use different flags somehow to indicate some positive and negative experiences on the island. So if we summarize somehow on the physical workshop what material and tools we need, we can see that we need a lot of post-its, large sheets of paper where the different questions are indicated, maps, stickers, or markers and pens. And for as mapping tools, we need large printed maps. So, and all the elements to be visible. Maybe we need diagrams on mind maps, and in some cases we also can use magnetic boards with different pieces. So it can be also, this is something that we use in sometimes in children's workshop in schools and so on. In terms of the digital tools now, as I said before, a lot of collaborative platforms have been created. Some of the most, I think, famous, I would say, it's Miro. It's the one that we will also use tomorrow. So if you want to get deeper how also a blended participatory planning exercise is implemented, join us tomorrow to see also some tools on practice, which it's like it's a board where different, what we saw on map, it's actually also really easy to create it online and play with some different stickers and post-its. A lot of mapping tools, a lot of, you heard about GIS and different mapping platforms and tools. These have also used a lot for online mapping exercises. I will talk about participatory GIS in the next slide. Polling and survey tools are also considered as participatory aspects, participatory tools. We can use surveys also in physical workshops to gather easier and have a better summary of the different results. Zoom meetings and spaces, and also sketching tools online, which can help us simultaneously work on that. Another tool that is used a lot in field trips, it's the data collection through and mobile data collection tools. So we have different apps that can found during mobile. So we can have surveys, interviews, observation, and questionnaires done online, which is also really important on to gather users' experiences around the city. So this is also very important when it comes to urban planning. And here we can see a little bit more details on participatory planning GIS, which is a method of using GIS technology to involve communities and stakeholders in spatial decision making. The maps are not created, it's created with the community and not for the community. So we have a basis where in most of the cases, different questions are included and the possibility of indicating different things on map is given. So it helps, of course, it's an exercise that in most of the cases need a more updated skills of computer literacy, but it is also easy to navigate. So it's like a more advanced process like of a questionnaire. So it has this spatial dimension that at least urban planners and regional planners find it extremely useful when it comes to decision making. The key benefits of such tools empowers participants to contribute with spatial data. So we can add, for example, places that are most visited around the neighborhood, places that have some negative characteristics or some positive characteristics. So it is easier to indicate the specific problem, not only around this a road, but on the specific point that this challenge happens. Of course, all these approaches can be blended and integrated. So combining digital platforms with physical tools can ensure also inclusivity and accessibility issues, because when in most of the cases when just online tools, the online tools, of course, can gather a group of interested stakeholders. We can have an online workshop with 50 people, but having 50 people in a physical workshop, you need more resources and more facilitators. So also staff to support this process. But also digital tools have a lot of limitations, such as people, elder people, or people that don't have this literal digital literacy are in most cases excluded. So when blended exercises, like you can have a physical workshop and then you can have a follow-up online and so on, can ensure transparency, inclusivity, and engagement in a higher level. Of course, combining all these tools can provide the flexibility and it can be adjusted to different participant needs, as I said, and of course increases the level of the amount of data that we eventually can gather. The tools for these blended exercises are, of course, for example, if we are in a physical workshops, you can use QR codes and have, for example, to share some digital tools, or we can have inclusive toolkits like multilingual material and all the forms in an accessible way. Thank you very much. I will also say here that please be with us tomorrow to see a lot more information about the participatory planning exercises. And I think if you take part in this actually hands-on workshop will improve your understanding on how this activity done and how as urban planners we can think and collaborate in order to create an effective participatory planning exercise. Thank you.